Suppose you have planned a vacation to Goa, and in one fine evening, while strolling in the beach, you step into one of the old casinos in Goa. Now, in casinos, there are different kind of games like chess, solitaire, and suppose you play one of the old school coin games. Now the game goes like this. There is a coin with its head facing up, and first it's the computer's move. The computer may or may not flip the coin. The computer has the choice. But what the computer is doing is not revealed to you. And then it's your turn. You may choose to flip the coin, and then your move is not revealed to your opponent, that is the computer. And finally, it's the computer's chance. At the end of the 3 rounds, the result is revealed. If the outcome is heads, then the computer wins, and if the outcome is tails, then you win. Now, by simple mathematics, you can predict that there is a 50-50 chance of winning this game. And when this game was carried out on a normal classical computer, yes, the result is as expected. The player wins about 53% of the times, and the computer wins for 47% of the times. Sounds boring, right? In the era of games like PUBG and FIFA, this old primitive game will obviously sound boring. But what if we played this game on a quantum computer? Can anybody predict the result? You can see the quantum computer achieves an amazing winning streak of 97%. Seems like magic or cheating. No, it's quantum physics in action. See, you cannot build a electric bulb by building better and better candles. An electric bulb is completely different technology altogether. Similarly, you cannot build a quantum computer by building better and better supercomputers. Quantum computers are completely different based on the science of quantum physics. Since the age of 1960s, the power of the human brain machines, the computers, have grown exponentially. As you can see, the computers have become smaller and smaller in size, as well as they have become more and more powerful. The smartphone that you are holding in your hand is more powerful, has more computational power than the earliest computer. Now, a computer basically contains circuit chips for all its arithmetic operations. Now, the circuit chip contains some modules, each of which has some specific task. Now, the modules operate by using logic gates, and each logic gate consists of transistors. Now, what are these transistors? These transistors are basically simple electric switches which can allow the electric current, electrons to flow, or it can block the electrons from flowing. If it allows the electrons to flow, then it will be 1, and if the electrons are blocked, then it's 0. So the basis of all computation is the bits. Any information is stored in the form of bits. Now, we have reached a physical limit of developing our computers. We cannot make our computers any more powerful by the conventional method. There is a limit to how small we can make our transistors. You can see a transistor, the smallest transistor that Intel has made is about 14 nanometer, which is 8 times smaller than the HIV virus. And it is 500 times smaller than the red blood cell. The picture here is up to the scale. You can compare the size difference. So we cannot make our transistors any more smaller. Why? Because of the strange phenomenon known as quantum tunneling. Now this might sound very weird in real life. Suppose there is a wall and you throw a ball at the wall. The ball can never go through the wall. But when it comes to objects close to the size of electrons, the electron can pass through this wall. The transistor will not have the power to block the electron anymore. The electron will simply pass using the phenomenon of quantum tunneling. So we have reached an end of making our transistors any smaller. All this sounds very weird, right? Nobel laureate physicist Sir Richard Feynman once said, if you think you understand quantum mechanics, you don't understand it. So, scientists have developed a completely new technology. Now, the basis of computation in classical computers are bits. Now we have quantum bits known as qubits. Now qubits do not have a binary identity. They have a very fluid identity. Their identity cannot be specified like 0 or 1. The qubit's state is a superposition of 0 and 1. So a qubit can in a state 30% 0, 70% 1. So this is very weird because in real life we don't see a coin 30% head, 70% tails. We see definite states, either head or tail. But quantum is really weird. Now, to make qubits, we use the electron spin. Now, the electron may exist in a spin up state, which can be assigned as 1, and or the electron may exist in a spin down state, which can be assigned as 0. Now, in reality, the electron do not exist in any definite state. The state of the electron, the spin state, quantum spin state of the electron is a superposition between the upspin and downspin. But when the electron's state is measured, it collapses to one definite state. To explain this, I'll just use a simple thought experiment devised by Sir Erwin Schrödinger. That is the Schrödinger's cat experiment. Now inside this box, the cat is in an enclosed box. Now there is a 50-50 chance of this poisonous jar breaking. If the poisonous jar breaks, then the cat will die. And if it does not break, then the cat will live. Now according to Schrödinger, the cat is in a superposition of death and life. The cat is dead as well as alive in the same time. But when you open the box, you will find the cat to be either alive or dead. So when you observe, when you make a measurement, it collapses from multiple superposed states to one single definite state. Same is the case with qubits. Now, why qubits are special? The question may be asked. Suppose you are given 4 bits. How many different data can you store? By simple permutation and combination, you can find that 16 different combinations can be there. For example, 0000, 0001, and like this. On the screen, you can see 16 different combinations are possible. Now, when you are given a set of 4 bits, you can store only one of the 16 possible values at one particular time. But using quantum bits, one quantum bit can be in multiple states. Using that phenomenon, you can store all these values at a single time. That's what makes quantum bits very special. So quantum computers can perform multiple operations at the same time using special quantum algorithms. And at the end, the result that you require, you measure only that result. Now, you can see the amount of classical information contained in n qubits is equal to the amount of information contained in 2 raised to the power n classical bits. So you can see it's exponentially large. The power of exponentiation is really great. Now, the classical algorithms does not work for quantum computers. For them, we have specially designed quantum algorithms. Now, quantum computers will not replace your home computers, obviously, but they are vastly superior in certain areas. Let us check out. First of all, database searching. When you search database, if a classical computer takes n seconds, then the quantum algorithm will take root over of n seconds. So suppose 1 million seconds is taken by a classical computer, then the quantum computer will take only 1000 seconds. You can see the drastic improvement. The next and the most dangerous thing is that it can destroy IT security. So suppose when you email somebody or when you send a message in WhatsApp to somebody or when you pay through credit card or UPI, then your data is secured through encryption. Now the principle of encryption is a computer science topic. I will not delve in deep into it, but there are 2 main things, the private key and the public key. Now the public key and the private key are mathematically linked. Now when everybody has your private key, suppose somebody is mailing you or somebody is taking payment from you, everybody in the world has the private key, the public key, but not your private key. But using mathematics and hidden trial, hackers can calculate the private key using the public key. But using normal computers, it would take thousands of years to complete. So, but using quantum computers, if the hackers get quantum computers in their hands, then they can simply calculate the keys using very less amount of time. Another big impact of quantum computers will be in the drug development. So, for special drugs, for example, medicines for cancer or Alzheimer's, the molecules, the specific molecules, research and development has to be done on specific molecules. And using normal computers, simulations cannot be done. But using quantum computers, we can simulate the real life behavior of the molecules, and we can predict how the medicine will behave, how it will react with the enzyme, and everything can be predicted using quantum computers, which was not possible by normal computers. And next thing, one of the very weird phenomenon is entanglement. Quantum entanglement can be called as spooky action at a distance. See, quantum entanglement is a very weird phenomenon. 2 qubits can be entangled over space and time. So when two qubits are entangled, by changing the status of one qubit, we can impact the another qubit. Now what is the application of this? Teleportation of data. See, when we send information from Earth to Mars, it takes about 8 minutes, not using normal technologies. But using quantum teleportation, we could transmit the data in a super fast rate, instantaneously, faster than the speed of light. This is only possible due to the entanglement. Now, the quantum rush has begun. All the big companies like Amazon, Google, IBM, they're investing largely on this technology. And it is expected the world's first trillionaire will be someone who harnesses the power of quantum computers or uses mines deep space asteroids. Now, currently Jeff Bezos, the owner of Amazon, is the world's richest man with $186 billion in his account. But the world's first trillionaire will be somebody who can harness the power of quantum computers. In October 2019, Google made a big announcement. It announced that its 53-qubit quantum computer named Sycamore had achieved quantum supremacy. Now, what is quantum supremacy? All these applications that I was talking about till now were all theoretical, were all just imagined by scientists, that theoretical. But Google first showed that using a quantum computer has achieved certain tasks which other classical computers will take thousands of years to do. We get to be the explorers in a quantum wonderland. Who knows what applications we will discover next? We must tread carefully and responsibly as we build our quantum future. And for me personally, I don't see quantum physics just as tools to build quantum computers. I see quantum computers as a way to probe the mysteries of nature and reveal more about this hidden world outside of our experience. How amazing that we humans, with our relatively limited access to the universe, can see far beyond our horizons using our imagination and ingenuity. And the universe rewards us by showing us how incredibly interesting and surprising it is. The future is fundamentally uncertain, and for me, that is certainly exciting. I would like to extend my deepest gratitude to all these people. This is Shohini Ghosh. I took a lot of content in my presentation from her TED Talk. I took a lot of slides and graphics from a German channel named Kusgesat, who made a video on quantum computers. I took a lot of content from Derek Muller, who is the creator of the channel Veritasium. I also took a lot of insights and knowledge from Professor Andrea Morello, who is a quantum physicist, in his interview given to Veritasium. Thanks a lot.